Hello guys, my name is Minhajul Islam and I am delivering the topic magnetic optical activity from the book M. Wolkenstein. In 1845, Faraday wrote in his diary, "At last I have succeeded in my attempts to magnetize and electrify a beam of light and illuminate a magnetic field line. Thus was discovered the magnetic rotation of a plane of polarization of light propagating along the direction of magnetic field. This phenomenon was called the Faraday effect. What was written by Faraday in his diary has only a fugitive meaning. The magnetic fields acts not on the line but on the substance that exhibits circular figurance in the field. The Faraday effect, magnetic optical rotation, and magnetic circular dichroism has relatively recent found important applications in molecular biophysics. The angle of rotation, defined by formula that is shown in 5.14 figure 5.14, is proportionally to the magnetic field strength h, that is Becquerel's formula. In this formula you can see where V is the magnetic rotation constant, that is the Virchow constant. In classical electronic theory, the Faraday effect reduces to the Zeeman effect. An electron, which is regarded as a harmonic oscillator, oscillates in the absence of magnetic field with a circular frequency. In a magnetic field directing along the light beam, a spectral line of frequency is split into the two left and right circular polarized components. The splitting is equal to 2, where omega h is the circular frequency of the Lamar's precession. You can see here the formula. We have just obtained Becquerel's formula that is in figure 5.45. It agrees approximately with experiment in a region far away from absorption bands for diamagnetic substance. The true theory of this effect can only be constructed on the basis of quantum mechanics. Under the influence of magnetic field, several phenomena occur. First, the ground energy level of the electronic system. Second, the right and left waves, there appear different transition probabilities. The origination of MOR and MCD is illustrated in the figure 5.21. In the absence of a magnetic field, there are true electronic transitions from the non-degenerated ground level, that is epsilon naught, to a double degenerated excited level, that is epsilon E. The frequencies of the transition corresponding to the right and left waves and the corresponding refractive indices and extension coefficients concede. The curves are shown with an opposite sign for convenience. Finally, the effect of type C arises with a result in the degeneration of the ground state, that is epsilon naught, the elimination of degeneration by the magnetic field, and the appearance of the difference in population of sublevels in accordance with Boltzmann's law. The C-type effect are asymmetric in MOR and symmetric in MCD. You can see in this diagram the rigorous quantum mechanical theory gives in the region of absorption the specific rotation. You can see here are some formulas regarding this. This formula, in figure 5.53, it transforms to the expression of contribution of the zero goes from J transition to the rotation far away from the region of absorption. If we put 0 in it, the magnetic circular dichroism is described by the ellipticity. You can see here another diagram for that. The Faraday effect, it is no way connected with the natural optical activity. It is observed in substances composed of both chiral and achiral molecules. When the mirror reflected light ray is passed again through an optically active substance, the rotation is compensated for and disappears, while the Faraday effect is double. These experimental observation of anomalous magnetic rotatory dispersion, that is AMRD, and magnetic circular dichroism, it is successfully carried out on systems with a strong magnetic rotation at a relatively weak absorption. For example, porphyrin compounds, heme containing proteins, chlorophyll, etc. The effect is proportionally to H, and therefore it is especially strong in magnetic fields created by superconductors and amounting to 50,000 Gauss and upwards. Under ordinary conditions, fields up to 20 to 30,000 Gauss can be produced. The relative values of MCD for various organic compounds are as follows: about 100 for porphyrins, about 3 for annullins, about 0.2 for purines, about 0.00002 for cyclohexane. The Faraday effect for heme containing proteins greatly depends on the electronic states of heme and the conformations of the protein. In this figure 5.22, we can see the AMRG curves and absorption spectra of the native oxidized and reduced, that is ferriform and ferrous cytochrome C. The fine structure of MOR of cytochrome C is clearly seen. No such fine structure is present in the absorption spectrum. The high sensitivity of AMRD and MCD makes it possible to study various cytochromes in suspension of submitochondrial particles that you can see in another chapter. Absorption spectra do not offer such possibilities. Some of the applications of the Faraday we can study in the hemoglobin and myoglobin, as well as in it will be also considered for these things. Thank you.